Hey everyone, let's talk about something that's all around us, the wind. For centuries, people have used the power of the wind to sail ships and grind grain. Today, we have a really important job for the wind making clean electricity. Our planet is getting warmer, and we need to find ways to get energy that don't release harmful greenhouse gases. Wind energy is a fantastic solution. It uses the moving air, which is a resource that never runs out, to spin giant blades and generate power. This helps us create a cleaner, greener, and healthier world for all of us. It's science in action, and it's pretty cool. The big, tall wind turbines you see in fields or out in the ocean are doing a great job. They are amazing machines. But they have a little problem. Down here, close to the ground, the wind can be a bit unreliable. Sometimes it blows hard, sometimes it barely blows at all. The wind's speed changes because it gets slowed down by things on the surface, like hills, buildings, and trees. To get the most power, wind turbines need a strong, steady breeze. When the wind is slow or inconsistent, the turbines can't produce as much electricity as they are designed to, which makes it a challenge to power our communities consistently. So, scientists and engineers started thinking, where can we find better wind? The answer was right above our heads. If you go higher up into the atmosphere, the wind is much faster and more consistent. It's a huge, untapped river of energy flowing thousands of feet in the air. The challenge was figuring out how to get a turbine up there. You can't just build a tower that's a mile high. That would be incredibly difficult and expensive. This is where a brilliant new idea comes into play. What if the turbine could float? This idea led to the development of airborne wind energy systems. Imagine a wind turbine that isn't stuck on the ground, but floats high in the sky like a kite or a blimp. That's the basic idea behind floating wind turbines. These incredible devices are designed to rise above the turbulent, slower winds near the surface and tap into the powerful, steady currents high above. By reaching these altitudes, they can capture much more energy than their ground-based cousins. This isn't just a small improvement, it's a giant leap forward for wind power. It could change the way we think about getting clean energy, making it possible to generate electricity almost anywhere on Earth. So, how do you make a wind turbine float? You can't just tie a rope to it and hope for the best. The engineers at a company called Shanghai Aowei Siuan Energy Technology, or SAW, came up with a very clever solution for their turbine, the S1500. They designed it to be like a high-tech blimp. The main body of the turbine is a large, inflatable shell. This shell is filled with helium, a gas that is lighter than air. You might know helium from party balloons that float up to the ceiling. The same principle lifts this massive turbine into the sky, allowing it to soar effortlessly. But it's not just helium doing the work, the entire structure is built using incredibly strong yet lightweight materials. The main frame and the blades of the turbine are made from carbon fiber composites. Carbon fiber is a material that is stronger than steel, but weighs a lot less. This is super important because when you're trying to make something fly, every ounce counts. By combining the lifting power of helium with the strength and lightness of carbon fiber, the S1500 can ascend to great heights without needing a heavy, rigid structure. It is a fantastic example of using advanced materials to solve a big engineering problem. Once the turbine is high in the air, it needs to stay in place and send the electricity it generates back down to us. The S1500 is connected to a ground station by a strong tether. This tether does two jobs at once. First, it acts like a super strong kite string, anchoring the turbine and preventing it from flying away in the powerful winds. Second, it contains the electrical cables that transmit the generated power safely back down to the ground, where it can be fed into the electrical grid to power homes and businesses. This tether is the crucial link between the high-flying generator and the people who need its energy. The real genius of this design is how it positions itself to capture the most wind. The floating turbine is not just a passive balloon, it's an active energy harvesting machine. It has fins and control systems that allow it to orient itself perfectly into the path of the strongest winds, just like a weather vane points into the breeze. This means it can constantly adjust its position to maximize its power output. By floating high above the ground and actively seeking out the best wind, these turbines can operate much more efficiently and for more hours in a day than traditional turbines, which are stuck in one spot. Let's look more closely at the S1500 and what makes it so special. This isn't your average wind turbine. Its specifications are truly impressive and show just how different it is from what we are used to seeing. The entire floating unit weighs only 2.5 tons. That might sound like a lot, but for a power generator of its scale, it's incredibly light. For comparison, a traditional ground-based turbine with a similar power output can weigh hundreds of tons. This massive weight reduction is key to its ability to fly, and is thanks to its smart design and use of those advanced carbon fiber materials we talked about. The S1500 is designed to operate at an altitude of about 300 meters, which is nearly 1,000 feet up in the air. That's as tall as a skyscraper. At this height, it leaves the slow, gusty surface winds far below and enters a zone where the wind is much more powerful and reliable. Instead of one large heavy generator, the S1500 uses a clever system of 32 smaller micro-generators. This distributed system helps to spread the weight evenly and makes the whole device more efficient and easier to maintain. It's a great example of thinking differently to achieve a better result in energy generation. The development of the S1500 didn't happen overnight. The team at SAWS took a step-by-step approach, building and testing smaller versions first to perfect their technology. They started with a model called the S500, which helped them prove their core concepts of a floating, helium-filled design. After learning from that, they built the S1000, a larger and more powerful version that brought them closer to their goal. Each prototype provided valuable data and lessons that were incorporated into the next design, leading to the highly advanced S1500 model that is being tested today. This careful, scientific process is how great innovations are made. The company's founder, Zhang Jianjun, has a vision that goes even higher. The ultimate goal is to create turbines that can reach the jet stream. The jet stream is a current of extremely fast-moving air located many miles up in the atmosphere. The winds there are incredibly powerful and almost constant. If we could tap into that energy, we could generate a tremendous amount of clean electricity. Reaching those altitudes presents huge new challenges, but with the progress made so far, it is a future that engineers are working hard to make a reality. It's a bold ambition that could revolutionize our energy systems. So, what does all this mean for our planet and our need for clean energy? The advantages of floating turbines like the S1500 are huge. Their ability to tap into stronger, more consistent winds means they can generate more power, more of the time. They can produce electricity with a higher capacity factor, meaning they are working at their full potential for a larger percentage of the day compared to ground-based turbines. This makes them a more reliable source of renewable energy, which is a critical step towards replacing fossil fuels and fighting climate change. It's about making wind power work smarter, not just harder. One of the most exciting things about this technology is its potential to bring wind power to new places. Traditional wind farms need large areas of land or shallow coastal waters with specific wind conditions. But floating turbines are much more flexible. Because they don't need a massive foundation, they can be deployed in regions that were previously unsuitable for wind energy, such as mountainous areas, deep water offshore locations, or even islands that rely on expensive imported fuels. This could give communities all over the globe access to their own local, clean, and affordable source of electricity. Think about it. A floating turbine is also much less visually intrusive than a giant field of traditional turbines. They fly so high that they are barely visible from the ground, and they are nearly silent. This helps to address some of the concerns people have about the impact of wind farms on landscapes and local communities. Furthermore, because they are lighter and use fewer materials, their manufacturing process has a smaller environmental footprint. From top to bottom, these systems are designed to be a more sustainable and harmonious way to harness the power of the wind. It's a win-win for people and the planet. In conclusion, China's S1500 floating wind turbine represents more than just a new gadget. It represents a new direction for the future of energy. By thinking outside the box, or in this case, off the ground, engineers have created a way to unlock a vast, powerful, and clean energy source flowing high above us. This technology has the potential to accelerate our transition to a world powered by renewables, providing reliable clean energy to millions and helping us build a sustainable future. The wind is waiting, and thanks to science and innovation, we are finally learning how to reach for it. Consider the following. The future of energy is looking up.